Hey, Miss Sams.
Yeah.
You know, it's graduation day here in Woodland Park.
It is.
And so we're about to head to graduation.
We are. And so we're in my car here. We're going to drive down, but we figured this would be a good opportunity to utilize a nifty little tool that happens to be in my car.
What is that tool?
It's the carmometer.
The carmometer.
The carmometer.
Yeah.
Yes.
Yeah, we should talk about the carmometer. So
Yeah.
what is it? What the heck is a carmometer?
It's a thermometer for my car.
Oh, I see.
Just tells you what it is outside. So when you're inside and the air conditioner's cranked and it's 108 when you're driving in LA. Or
Oh,
something.
you can see. So what's the temperature in the car?
Well, let's grab the camera and we'll find out.
All right, I see.
Okay. See all the car seats? I have twins, by the way. That's why I have two car seats there, and that's for my son.
This is a really big car.
Oh, that's huge. We had to get a bigger car when we had twins.
Oh, I see. It looks like it's 59 degrees.
59 degrees outside.
That's pretty cold. It's
Yeah,
May
that's Fahrenheit.
22nd.
May 22nd, 59 degrees. Yeah, it's kind of overcast and it's rained all night and kind
Yeah.
of gross like that. Now, let's look at a couple other things in the car. Right above there, we have the mileage. That's my little trip counter, 195.2. That's how many miles I've driven.
That'd be like a quantitative measurement.
Yeah, that's how far I've driven since I got gas last time.
Yeah.
Over here we have RPMs, rotations per minute. That's how fast my engine is turning over.
Yeah.
Okay.
That's quantitative.
My gas gauge there, it's right on half.
That's kind of just qualitative.
Yeah, that's kind of qualitative. Okay, we don't know how many gallons are in there. Now, I do because I know I have a 22-gallon tank. If it's half full, I've got 11 gallons in there, so I can do some mash.
To probably one significant digit.
You're right. Now, there's some, the temperature of my engine that says cold and hot.
Yeah.
So that's a qualitative measurement.
Yeah.
Okay. Over here, we've got my miles per hour.
Ooh, speed.
Yeah, so we have a unit divided by another unit.
Yeah,
okay?
so that's like distance and
Yeah,
time.
and then in the gray numbers there, I have km per h, kilometers per hour.
Oh, yeah. That's another measurement.
Yeah, it is. So I've got lots of measurements in the car that you don't really think about.
Yeah.
But there they are, and we're going to talk to you about them
In this
a little bit more in this lesson.
So we will see you. Let's just keep going and let's learn about it. So as you can see, we're going to talk about what's called the SI system.
Yes.
And
that's kind of redundant, actually, because the S and SI stands for system.
I know.
It's kind of like going to the ATM machine.
Why is the ATM machine going to the ATM? Oh,
because the M is machine.
There you
The
go.
automated teller machine.
Yeah, that makes sense. Okay.
Yeah.
Hey, we're going to talk about dimensions, as we talked about in the little webcam thing here just before.
Yeah.
That we've got different quantities.
Yes.
Now, these are the kind of the basic quantities that are measured in the world.
Right.
Length. Now, in the SI system, the System International is what it's called. It's French, I think.
Yeah. Well, that's where the standards live. The standards live in Paris. The standard kilogram, the standard meter, they're made out of platinum, and they live in Paris somewhere.
Paris. All right. And then we've also, the symbol is the meter. Now, in the non-SI system, we can also measure length in other units.
Inches.
Inches, yeah.
Furlongs.
Furlongs.
I don't know, some other ones, feet, stuff like that. Yeah.
Etc. So, by the way, on this table, you should copy this table down into your notes.
Yeah.
Okay, so you're probably going to hit pause a couple of times.
Yep.
All right, volume's an interesting one. Volume, here's volume right here. And the SI system is actually called a cubic meter.
Yeah, it derives it from length.
Yeah, so actually volume's a strange one. It's not considered a fundamental quantity.
No, it's a complex.
It's a complex one. So the actual unit is meter cubed for volume.
Now, most often in chemistry land, though, we measure things in liters.
Yeah. So liters, which is an L. So that would be an example
and
of a
often
non-SI.
milliliters as well.
Also milliliters, which of course symbol is little m, big L.
Yep.
All right.
Okay.
In mass, most of you this is kind of like the metric system. Maybe you learned that in elementary school or something like that. But it's a little bit different in that you've probably learned that the unit for mass is a gram. But in the SI system, the scientific system, it's actually a kilogram.
Right.
But
we still use grams.
Yes.
Yeah.
The other system, certainly grams is a non-SI system, and that's a G. I should say MS.
Yep.
Okay. Or
pounds, sort of. Pounds is actually a measurement of weight versus mass, and we'll talk about the difference of that.
Symbol for pounds is LB, so it's kind of weird.
Yes, libras or something like that in Latin.
Yeah, and so
has to do with scales and being fair.
Yeah. Okay. Density is grams per centimeter cubed.
Yep.
And that's the
cubic
density.
Centimeter,
or cubic centimeter. Oh, there we go. And so grams per centimeter cubed. That's that's the SI
now,
system.
you can measure density in any unit of mass over any unit of volume.
How about pounds per foot cubed? There's a weird one.
Perfect.
So if I had 1 pound, or if I had 1 cubic foot of something, how much would it weigh?
Yeah.
Okay. And temperature's a weird one. It's something called the Kelvin system.
Yeah.
We're going to talk some more about that. You've probably heard of Celsius.
Uh-huh.
and that's degrees C, or you might have heard Fahrenheit.
And that's degrees F. Now notice there's no degree sign in front of the K for Kelvin.
Yeah.
It's not degrees Kelvin, it's just Kelvin.
Okay, and we've got some more time. We measure time oftentimes. The main unit is seconds, not minutes or hours. So a non-SI unit would be minutes or hours. Pressure is something called a Pascal. Okay, there's also ones, we're going to also use one thing called ATMs or millimeters of mercury.
Yeah.
And we'll talk about that much later in the year. So
ATMs, it stands for atmospheres.
Yeah, like 1 atmosphere of pressure will be the pressure at sea level.
Yep.
We live at high altitude. If you are our student, then you know that. The atmospheric pressure here in the park is about 0.75 atmospheres.
Yeah, so roughly 3/4 of that what it is at sea level.
Yeah.
That what it is. That's why I don't teach English.
We're called folk today.
Yeah.
All right, this is the 4th podcast in a row. All right, joules.
Yeah.
Joules is energy.
You can also measure that in calories.
Yeah. Oh, I said energy. I should say calories here. That's right.
Yeah.
Calories. Yeah, I had my vitamin water. Actually, right here, my vitamin water says it has. I don't know what it says. It's got some calories in it. 10 calories.
10 calories?
10 calories.
So that's actually a kilocalorie. So that's actually 10,000 calories.
There you
Mr.
go.
Bergman.
I know, but that's actually a very small amount. So, an amount. This is an interesting one. This is a very, very important unit in chemistry land. We're going to learn about something called the mole. And oddly, the unit for mole, or the symbol for mole, is little
mole.
m, little o, little l. You don't put the e. You just drop the e, because I guess we're lazy.
We're lazy.
We can't use an m, because that's a meter.
Yeah.
So
we put mole. Now,
if you do ml,
yeah, we could do ml, but that's milliliters.
Milliliters, yeah.
So that's mole. Other amounts that you have commonly encountered would be like a dozen.
Yeah.
Or a ream, like a ream of paper.
Yeah.
Or a pair.
Yeah.
Okay? We use moles, and we'll talk more about that later.
Yeah, very important topic. And lastly, electric current is an amp.
Yep.
And that's just another
big
one.
A.
Yeah, big A. Okay.
That's what people used to call me because my name's Aaron. Big A.
The big A.
But I'm not very big, so.
Much tall.
No, I'm tall.
You're tall.
Kind of scrawny.
All right, so here, let's just, what dimensions are being used here in this experiment, or in this measurement?
We are measuring mass.
Kilogram is mass, so that's the dimension.
Yes.
All right, now miles per hour, that's kind of like two different
that's a length.
So miles would be length.
Over a time.
Length over time, yeah. All right, grams is...
That's a mass.
Mass, yeah, and then moles...
That's a quantity.
Per amount.
Amount, yeah.
Yeah, or quantity, same thing, really.
Yeah.
And then grams per milliliter.
That's a mass
That'd be a mass per volume. Or, what else could you say about
We can call that density. Density is grams per milliliter.
Or you could also call that mass per distance...
Cubed.
Because
milliliter is the same thing as 1 cubic centimeter.
Yeah, actually, that's a very important thing to write this down, guys. Again, 1 milliliter is equal to 1 centimeter cubed.
Very important.
That means if you had a box that was 1 centimeter. Now, a centimeter, by the way, just from a perspective, is about 1 fingernail width by 1 fingernail width by 1 fingernail width. That's a centimeter. So if you would have a box that was 1 centimeter by 1 centimeter by 1 centimeter, that would be the definition of a milliliter.
1 milliliter.
In fact, while we're at that, do you understand if you were to fill that box with water, not add the mass of the box, it would weigh 1 gram.
Right. That only applies to water because water has a density of 1 gram per milliliter.
Yeah, other substances have different densities. And actually, that is the definition of how they...
that's how they came up with the SI system. It's all based on water.
Yes. Yeah, in fact, the temperatures, Celsius scale.
Celsius scale is based on water.
Actually, it's based upon water and also the meter.
Yes.
And what a meter is, which is defined by some things.
Mr. Bergman is making his computer beep.
Yeah. All right. Temperature.
Temp.
We saw the temperature in the
carmometer.
Carmometer. I love that word.
Isn't it great?
The carmometer.
Yeah.
But we need to talk about the different kinds of temperature. Now, we really don't care much about Fahrenheit, guys. Sorry, scientists don't even use Fahrenheit. So we've got the one you're familiar with is probably degrees Celsius. All right. A couple things about degrees Celsius is at 0 degrees.
Water freezes.
Water freezes. Speaking of
now,
water.
it's only water. Not everything freezes at 0 degrees Celsius. That is another very common misconception.
That is true. Do you understand that, like, I have, this table right here.
Yeah, it's made out of metal, made out of steel.
It's out of steel, and it's
frozen.
It's frozen.
Yeah.
Frozen? Yeah. It doesn't feel too cold to me.
It's a solid.
But see, frozen means it's a solid.
Right.
All right, but water, we know, freezes at 0 degrees Celsius, and at 100 degrees Celsius, water boils.
Is that 100?
100
Your handwriting
degrees.
is starting to look like mine. Notice Mr. Bergman does all the writing. That's because my handwriting is completely illegible.
I wrote it better now.
Yeah.
So 100 degrees Celsius, water boils.
Good.
Okay,
let's
but
convert.
what we really care about is that there's a conversion between this Celsius and this Kelvin.
Right, the Kelvin temperature.
So degrees Celsius.
Okay, Celsius.
Plus
273.
273 equals
the Kelvin.
Notice I didn't write degrees Kelvin.
No,
it's
just Kelvin. So Celsius plus 273 gives us Kelvin. Just remember that 273 number.
All right, so let's do some practice. So let's say I have, let me see.
25 degrees Celsius.
25 degrees Celsius.
Pretty typical room temperature.
What is that in Kelvin?
Well,
what
let's
would I do?
add 273.
Just add 273. Now I don't even need a calculator, Mr. Sams, on that one. That's too easy.
298.
298 K. All right, let's take a really cold temperature. Let's say it's negative 150 degrees Celsius, which is really, really cold. That's colder than Earth has ever been.
All right.
The coldest recorded temperature, at least. We would then, of course, do what?
Add 273.
Add 273. And so we would then add that. We have a negative number, and we're adding 273 to it.
We get 123.
That'd be 123 Kelvin. Now, what if
Mr. Bergman wanted me to use the calculator. I didn't need to use the calculator.
Yeah, I was trying to do it in my head, too. All right, what if I have negative 273 degrees Celsius?
Okay.
All right, get the calculator. I hope you don't need one.
All right.
We're going to add 273 to that.
Right.
And you get
0.
0K.
Hey, by the way, we should note that there's no such thing as negative Kelvins.
Yeah, you
it's
can't.
It's an absolute scale.
And actually, the reason I picked this number, guys.
Yeah.
This is actually a famous temperature.
It's called absolute zero. By the way, there's a test question on your exam. What is the temperature in Kelvin at absolute zero?
0 Kelvin.
Yeah.
You can never. If you get something to 0 Kelvin, what's going to happen?
The universe ceases to exist. No, I don't know.
No, that's not true.
No? Okay.
It stops molecular motion because actually temperature, which I think we've talked about, is actually a measure of the average kinetic energy of a molecule. And so molecules are constantly in motion.
Yeah. They're either moving around or if they're in a solid, they just kind of vibrate.
And so they're kind of vibrating, but when you get it cold enough, they'll stop. And cold enough, the definition of cold enough is absolute zero, 0 Kelvin. Now we probably should go in the other direction. Okay, let's do a couple more, Mr. Sams. Let's say I've got
305.
305 Kelvin. What's that in degrees Celsius? What do you do there?
Subtract 273.
Yeah, we subtract 273. And what do you get there, Mr.
32.
32
degrees Celsius. No naked numbers. Let's try one more.
Well, what about 25 Kelvin?
25 Kelvin. So we subtract 273. So 25 minus 273, we get negative 248.
Negative 248 degrees? No, Kelvin.
No, degrees Celsius.
Degrees Celsius.
Yes.
Negative 248 degrees Celsius. I'm trying to remember. Okay, so that's how we do temperature stuff. I guess we're done.
Yep, enjoy.
Watch that thermometer.